Good day, dear learners. Today I will be talking about nuclear hazard and their effect. Now, this particular topic is the last topic of this particular week. So, the overview of this lecture would be that by the end of these 30 minutes, you'll be able to understand what nuclear hazards are, what is radioactivity, and the key terms like nuclear fission, nuclear fusion. Plus, you'll be also able to identify and classify the different types of nuclear waste, what are the sources of radioactive radiations. And lastly, you'll be able to analyze the causes, effects of nuclear hazard on human health, environment, economy, and society. So needless to say, this nuclear hazard, it's a anthropogenic source, you can say, because we have created this nuclear reactors, and if there is any fallout in the nuclear reactor, so of course it affects the human population. In fact, not only human population, it affects the plant community and animal community as well. But why another important point is you have to understand that if you're talking about hazards and this eventually it gets translated into a disaster because it's affecting the different communities. So definitely we have to also understand where are we creating this nuclear reactors, right? And these incidents that are taking place, what are they doing? What is exactly happening? So we find that these incidents, if there is any fallout, or any incident that is happening in a nuclear reactor, there's a tremendous release of significant level of radioactive materials, or even the workers, they can be exposed, or in general, the entire public also. So our primary concern following a nuclear incident or a nuclear accident are that the public health does not impact from the direct exposure to a radioactive fallout. So other than that, we do find that our concern could also be that if these radiation are penetrating any food material, or if you're consuming the food material, it is entering in our food chain as well. So it has a long-term exposure also, because the kind of radioactive material, if it is being deposited on any kind of material that we're coming in daily contact. So once we are in contact with the radioactive material, so it can lead either to a very acute radiation sickness or a very chronic state that could be cancerous as well. So nuclear hazards are no doubt, they are the threat by the invisible. Now this is something very, particular about this hazard that is taking place, that I would say that it is invisible. It is odorless contamination of the environment that is taking place. You can't see it, you can't smell it, but you never know, where you are being exposed with these kind of radiation. And the radionuclides, basically, if you know, you must have studied chemistry, you can understand how they emit in different energy particles like alpha, beta rays, and so on. And of course, electromagnetic radiation in the form of gamma rays. So the radionuclide or radioisotopes, there are some examples that I have just listed out, like uranium-235, 238, thromium, potassium, radium, carbon, etc. They're unstable nuclei. Now, once it's unstable, it releases ionizing radiation in the form of alpha, beta, and gamma rays. So there's a spontaneous emission of the particles and rays by an unstable nucleus is called a radioactivity. Okay, and contamination of the environment with these radiation is called radioactive or nuclear pollution. Now, you have to understand, when we are talking about radioactivity, so we have to understand two terms that comes automatically: fission reaction and fusion reaction. So they are the fundamental processes that are taking place. And might I mention you here that in the nuclear reaction, tremendous amount of energy is released, and we need that energy. We need that energy for our daily purpose, and because we're exhausting the non-renewable energy, so nuclear energy is one of the alternative. So what kind of reactions are taking place? So first is nuclear fission reaction. Fission meaning that the particular nuclei will be split into a smaller nuclei after being struck by a neutron. Now, this actually releases a large amount of energy along with additional neutrons and gamma radiation. So this additional neutron will then trigger the further reaction. So that is why what we call is that creating a chain reaction, which is used in the nuclear reactor. And that is how the energy then is used to generate electricity. Now you can see here also in the diagram how one nuclei is split into two. The heavy element will be split into two lighter element and releasing tremendous energy. Now coming to nuclear fusion, that is combining the light elements together to form another larger, heavier nuclei. Now this process is very common, we can say, in stars and in sun that is taking place. So in sun especially, we find that hydrogen nuclei fuse to form helium, releasing massive amount of energy in the form of light and heat that we perceive, that we see, and that we utilize. So unlike fission, fusion, it produces less radioactive waste and has a higher energy yield. So what is radioactive radiation? Radioactive radiation are basically the three radiation that I talked about is alpha, beta, and gamma. So if we talk about alpha particles, they have a very low penetrating power and they cannot pass through the outer layer of human skin. So they're not that much harmful, but when the source remains, only when the source remains outside the body. However, they carry also some kind of high energy, and if alpha emitting substances, they enter the body through inhalation, through ingestion, or even open wound, they can cause severe internal damage to tissues and organs. Then in contrast, the beta particles, they have greater penetrating power than the alpha particles and can pass through the skin to some extent, potentially causing both external burns and internal damage if radioactive material enters the body. Now, if we talk about nuclear waste, so there are the three categories are given. High level waste, that is almost 3%, that is spent fuel contains 95% of radioactivity. 7% is the intermediate level waste, which used filters, steel compartment, and it has 4% of radioactive waste. And 90% of low level waste, which contains 1% of radioactivity in the nuclear waste. Now coming to high level waste, which is the most dangerous type, you can imagine, because there's so much radioactivity is there. So it requires cooling systems, and it has to be secure. The waste has to be secured enough so that nobody is exposed to it, right? So high radioactive liquid waste produced during the processing of nuclear fuel is the example of it. Then intermediate level waste, you can give the example of reactor components, chemical sludges, metal pipes, resins, and contaminated machinery parts as well. Low level waste can be even in the form of your contaminated gloves, the protective clothing that you're wearing, paper, tools, filters, medicine syringe, it can carry. So it is usually seen in the hospitals, laboratories, and nuclear power stations. So the causes of nuclear hazards, you see in this table, you see the source, cosmic, terrestrial, and internal, and the description is given accordingly. You can just pause and look through what are the natural causes of radiation in the form of cosmic rays, terrestrial rays, and internal rays, right? Now, anthropogenic cause of radiation, that is our main concern, because when you're handling nuclear waste and disposal, right? Since it is not chemically or biologically degraded, it is stored, it is sealed, it is, radiation shield containers, and they're disposed of in remote areas or abandoned, salt mines and things like that. So damage to storage system may still cause leakage and pollution. Then there's another type, the use of radioactive materials in defense weapon production. The bombs are being made, nuclear weapons are being made, especially and if there is some accident during the formation or during the production of the defense weapon, that also causes the exposure. The nuclear exposure and detonations, this testing, nuclear weapon testing, wartime explosion during the 20th century, which caused massive human-induced radiation pollution. Even the mining and processing of radioactive ores, the whole mining process, when you're extracting the ores, such as phosphate mining, can also generate radioactive materials. And nuclear accidents, We'll be dealing in detail the different accidents like the 3 Mile Island accident, the Chernobyl disaster, that also had a detrimental effect on the environment, and it affected the human life as well. So use of radioactive isotopes in medical industries and research applications, like, the diagnostic centers, they're using X-rays, radioactive isotopes, used as tracers and treatment of cancers and other ailments, that also exposes the patients to radioactive material as well. Now, in this diagram, you can see that whenever there is a fallout, especially during the testing of nuclear bombs and nuclear weapons, so the key image that comes, especially if I take the example of Hiroshima and Nagasaki, it's the mushroom type cloud that comes, right? So it can be in the form of mushroom cloud, it can be in the form of rising fireball, or shock and heat wave, or as a fireball radiation. So these are the different types in which a fallout pattern can occur. Now, what is the effect of nuclear hazard? Now, understand this, that when radioactive contamination is taking place, so it is measured in becquerels or curies, right? It's a quantifiable amount of radioactive material that is present. And exposure, of course, to these high level of radiation within a short time can cause, nausea, vomiting, and so on. Remember when I told you it's invisible, it's odorless. It's only when it starts, the symptoms starts developing that we understand that we are being exposed to it. So there's an immediate health effect is in the form of sickness, nausea, vomiting, and skin burns. Long-term would be in the high risk of cancer, especially of thyroid, lung, leukemia, and genetic mutation as well. Now here, you see that this is a table in which the dose, which is given in gray, the symptoms, the mortality rate without care and with care is given, that how this radiation dose affects on human body. Take a pause and you can look at the table and you can understand how the mortality will increase if the human body is exposed to the radiation. Then environmental impact, that is contamination of air, soil, water. So airborne radioactive particles can travel anywhere, right? Through air it can travel through water or soil. So of course, it will have a long-lasting effect. Then ecological consequences are also there. The contamination of natural habitat can disrupt the entire ecosystem and it can affect the food chain, leading to the decline and extinction of plant and animal species. Now comes the societal, the economic and the societal impact. How much burden a government faces in case if there is a fallout, nuclear fallout, right? The cost it includes to clean up the anti-contamination efforts, and then compensation for affected individuals, and of course the healthcare expensive. It is really expensive, managing all that. Then there's social disruption as well, because it leads to psychological trauma and loss of livelihood. And also there is a public perception and stigma that communities or people who are affected by nuclear disaster, they often face kind of a societal stigma, making it very challenging for the residents to return to the normal routine, the normal life, and rebuild their life. Or in fact, the resilience capacity reduces in the individuals who are affected by the nuclear disaster. Now coming to the prevention of nuclear hazard. So how can you prevent it? See, because radioactive, like I said, it's odorless, you cannot see it, but you have to prevent it. It is happening around us. So the key preventive measure is leak-proof containment, especially during the transport and storage. You're in a traffic light, a truck comes right beside you. You never know what it is carrying. It might be carrying some kind of a container with the radioactive material. And just because you are adjacent to, your car is adjacent, you are exposed to it. So it's important that whatever we are transporting, it should be leak-proof. Strict safety norms in power plants and hospitals, that's another thing. Radiation detectors, especially in scrap yards and borders, we should have the detectors, which perceives in radons the radioactivity. If you have seen the movie Transformers, how through radons they try to find the radioactive radiations, right? So it's there. So we do have the detectors like that. And public education, of course, about nuclear symbols, about safety rules, and controlled disposal in remote geological formations is equally important. So what are the major nuclear disasters? The first classical example that I can give is of Chernobyl nuclear disaster. And of course, there was a series made on this also. So if you got a chance to see it, you can see how the whole, the essence is being captured, how the steam explosion destroyed the nuclear reactor plant in Ukraine, and how it started killing people, the symptoms that started developing, and how they took care of animals of different plant community. And when they started seeing the symptoms, because it's difficult, to control such and how to quarantine the general public also, so they don't expose to the other people. So this was a level 7 nuclear disaster. Then Fukushima nuclear disaster, this is another kind of it happened in Japan in 2011. This was also level 7. And here the resultant was just that an earthquake, a tsunami took place. And that tsunami was it was caused by a 15-meter tsunami that disabled the power supply and prompted 3 reactors melt down in Fukushima Daiichi plant. And of course, there were 1,000 deaths occurred, and around 1 lakh people were displaced because of that. So you see that if the fallout is resulting, it disturbs the entire ecology, the entire ecosystem, and anything can trigger it. The nuclear reactor is there, even though it had flood walls, but that tsunami, when it came, it totally was devastating. So this was the second accident in the history to receive the most severe level 7 rating. Then came the 3 Mile Island, which is a nuclear accident in Pennsylvania in USA. This also suffered a partial meltdown in 1979. And in US, it was a more serious accident, which was caused by a relief valve failure, right? So after an unplanned shutdown causing severe damage to the core. So you see, all these incidents that I'm talking about, it's easy to just say that it was an accident. But that accident was devastating. It had a far-reaching and long-lasting effect. Now, talking about nuclear power plant, like I said, it's very important because we are generating huge amount of energy out of these power plants. So it's important to understand, like in India, where are these power plants and what capacity do they have? So this is a table. You can pause and have a look at it. The name of the famous nuclear power station in India, when they were established, where is their location, and what is their capacity. And of course, the operator is NPCIL, that is Nuclear Power Corporation of India Limited. And it is based in Mumbai, and it's a government-owned corporation of India that is basically responsible for generation of electricity through nuclear power. The nuclear disaster management in India, how it is being managed. So you have to understand that the system provides a coordination between 2 agencies. So first is the Atomic Energy Regulatory Body, that is AERB. This is the first body, and the second body is the National Disaster Management Authority, which is NDMA. Now, these are the key agencies and the measures. So the AERB, it sets safety standards and audits in nuclear facilities, whereas BARC, it's a technical support and radiation monitoring setup, and NDMA coordinates evacuation, how to rescue, and the rehabilitation. Now let's look at the management of the nuclear waste. So here, there's a diagram in which you can see the waste characterization, whether it is physical, chemical, or biological, how the nuclear waste is there, how it is pre-treated, treatment, conditioning, and later on disposal. So let's have a look at it. So waste characterization. So the first step is to analyze the waste. What is the physical form? Is it chemical composition? What is the level of radioactivity? And this basically helps to determine which will be the safest method of handling and disposal of that particular waste. Then comes the radioactive waste. So after identification, the waste is characterized as the radioactive waste that requires proper management. And of course, we have to follow some certain safety measures as well. Then comes the third step, that is the pre-treatment. What treatment are you giving? In this stage, the waste is collected, it is sorted out, it is prepared and further processed. So unnecessary materials may be removed, waste may be separated according to the type and the different kind of the radiation level. Now the fourth is the treatment. Now here basically what we're doing here, the waste is processed to reduce its volume or toxicity. So here the methods as compaction, filtration, chemical treatment or incineration may be used. Fifth stage is the conditioning stage. Now the treated waste which is now being reduced is converted into stable form and safe form. Why? Because we need to store it or either we need to transport it to some other geographical location for disposal. So it is often sealed in containers, either in cement or in glass blocks, which is known as vitrification. Then comes disposal. So we find that the isolation it's an isolation engineering model. So finally, the conditioned waste is disposed of in a specially designed underground or secure storage facilities to isolate it from the environment for longer period, right? Then exempt waste. Some waste has a very low radioactivity and does not require strict regulation or any special kind of a processing. So you kind of exempt that kind of a waste that does not require much of the attention or much of the processing. Then comes nuclear material. So nuclear material, this is after the treatment, this is the exempt waste and the nuclear material. So the certain materials recovered during the treatment can be recycled back, right? They can be reused in the nuclear reactor or other industrial applications. So here you see all the treatment in which we are trying to make the nuclear waste very safe for disposal. We're also treating it, reducing it, separating it to exempt waste and to the nuclear material, which can be reused again in the nuclear reactor or any other industrial application. So you see these are the different steps that are used in the nuclear waste management. So to conclude, what do we see? That nuclear technology, it offers significant benefits, tremendous benefits, you can say, in energy production and medicine and scientific research. But as it has the advantages, it also carries a lot of risk if it is not managed properly. So nuclear accidents can have a long-lasting impact on human health and the environment, underscoring the need for a stringent, you can say, safety measures and effective disaster preparedness. So we need proper management of radioactive waste, technological innovation, public awareness, and strong regulatory oversight, which is essential for minimizing the nuclear hazards. So the safe and responsible, you can say, use of nuclear technology is crucial for ensuring environmental protection and safeguarding our future generations. So you see, with this, I have come to the end of today's lecture on nuclear hazard, what are its causes and its effects. So these are the references which have been listed out. So if you want to have a detailed reading on nuclear hazard, you want to know more about it, you can click on it and refer to it. So with this, I come to the end of this week's series of lecture. So I'll be seeing you next week with another set of 5 series of lectures. Till then, take care of yourself and have a nice day. Bye-bye.